Example 1. Joe travels out of the country. He first rides his motorcycle at 65 kilometers an hour. After crashing, he hops a train and travels at 70 kilometers an hour. If the entire trip took 12 hours and he traveled 800 kilometers in total, how far did he travel by train? Step 1, let's identify some variables. So, let x represent the number of hours traveled by motorcycle. Let y represent the number of hours traveled by train. Please also recall the distance formula. Distance equals speed times time. So let's develop a graphic organizer to help us organize the data and to create two equations. So we have distance is equal to speed times time, and we're going to model equations for the motorcycle and the train and compute some totals. Step 1, let's look at the time. We are told that x hours was traveled by the motorcycle. We are also told that there are y hours traveled by the train. The total is 12 hours. Now let's look at the speed component. We are told that the motorcycle travels 65 kilometers an hour. We are also told that the train travels at 70 kilometers an hour. So now we can use the distance formula to compute the motorcycle and train parts. The distance is equal to speed times time. Now for the motorcycle, we know the distance is 65 times x. Combined, it's 65x. And similarly for the train, we know the distance is 70y, because the speed times time is 70 times y, hence the distance is 70y. We are also told that the distance traveled is 800 kilometers. So clearly we have two equations that can be obtained from the graphical organizer. Equation 1 deals with time. X plus y equals 12. Equation 2 deals with distance. Now you can choose a method of solving. I have chosen the method of substitution. What you can do is isolate x in equation 1, and you can do this so that you can later solve for y. Since we are called to solve for y, or the train factor, we want to solve for y rather than solve for x. So, first step here is to substitute the quantity negative y plus 12 into equation 2. And if you do so, you're going to have 65 times parentheses minus y plus 12 parentheses plus 70y equals 800. Distributing over the parentheses yields negative 65y plus 780 plus 70y equals 800. Collecting our variables and our like terms, we get 5y plus 780 equals 800. Put the 780 over to the right side, and you'll get 5y equals 800 minus 780. Simplifying further, you get 5y equals 20. And now if you divide both sides by 5, you'll get y equals 4. Therefore, if we sub y equals 4 into the distance formula for the train, we're going to find out how far the train traveled. When you do so, you get distance is equal to 70 times y, in this case 70 times 4, and distance is equal to 280. Thus Joe traveled 280 kilometers by train.